Okay, welcome all of you for the last minute preparation, uh, midterm preparation. Now, how do you want me to uh, take this forward? Okay, what I thought, let me tell you. Then you tell me whether it is okay. I will cover those. I'm not going to whatever I am covering. Don't think that it is going to come in the exam. Okay, first of all, okay, I have a disclaimer there because otherwise it will become like I am releasing the question paper here, which is not the intent. This is to only clear the doubts that you have, as well as what will be there, so that you are able to answer them without much of trouble. Because some of you had some issues, so let me consider that into take that into consideration. Okay, so what we will do, I have some topics which I will run through. Okay, you can just look at what I am planning. I want to explain this anyway. As I mentioned, that IA1 question paper checksum is going to come. I think there is nothing much actually to actually we are not aware of. Algorithm is given and sample question paper is given with a solution. It's a simple binary addition. So checksum is going to come, and which you can actually do. I don't think I need to cover it here unless you have some doubts on that. And RS232 waveform planning. Given a data for a particular parity, drawing a waveform is going to come, which is also part of IA1 question. And then I think those two only, right? Anything else? Because I am not asking anything on the subnet mask. Okay. And then something about the layers are going to come. Okay. All the 7 layers are there, which you are each layer. What is the responsibility of each layer? What is the role and responsibility? What are the protocols running in those layers? Just read about 7 layers, which is the default question asked in any exam or any interview. So that is anyway all the material is there. You can write about it. Okay, and then let me tell you what is CSMA and CAD. I will explain. Okay, then this is which is very important. You have to have a clarity on what the functionality of hubs, what does the bridge do, what does the switch do. Okay, so I thought I will take this lab 5 exercise and then explain you what exactly they do. Okay, um, that that is very important. Then what is forwarding table? Okay, all the three types of routing I want to cover. Okay, datagram switching, and then virtual circuits and source routing. Okay, then ARP is also important. So I want to tell you what exactly ARP request is, why we are doing. Though I have explained that in the first lecture of online, I will cover that also. Then this is very important. I can tell you that, as I mentioned in the classes of A and B, as well as in the lectures on online lecture, I said that I will swap one of these bridges, and then I want you to draw the STP, okay, spanning tree of the particular configuration, which is after this stabilizes, how it will look like. So there are some questions on people whether we should draw it on this picture or draw the whole tree format and then draw the STP. I suggest that drawing, see, on this picture is easy. So one option is you can do it on the question paper itself, but the problem is you please bring pencil in case if you have made a mistake, you can erase it and draw it. Then dotted line has to be shown, okay, properly, as well as the solid lines have to be drawn. So the picture what I will be showing in the question paper will not have any dotted line. It will all be a single solid line will be there. You need to I will be saying that some bridges are getting swapped, and then you have to draw the STP. So this I can run through that, explain it once here, because if you still have some doubts on that, I can clarify. Okay, so that's what I thought I will cover. Apart from this, um, let me think from the question perspective. See, I don't think that you just watch this and now you will get 100. Okay, I'm not assuring you 100 means 100%. You have to have read the slides, and I'm sure you have prepared it. See, one thing I can assure you that I won't be asking you when I say memory based means rote learning, okay, except for Ethernet header, okay, that I have already mentioned. There is a header because you are supposed to remember the header format and which field goes where and what are the functionalities of that. So that I don't call it as a memory based question. It is a default you are supposed to know. Okay. So apart from that, can you guys come on chat window and tell me whether should I cover anything else? I will give some 2 minutes for you. Nothing. Okay. Okay, so I want this to be interactive. Okay, more from people who have not attended the regular classes of mine, so that you get clarification. I don't know what you don't know, so I presume that you know something. So please feel free to interrupt me, either talk or session 4F. Okay, let me see. 1 second. The two bridges connected to LAN 1, LAN 2 loops in STP. Oh, that one. Okay. Okay. Uh, Let me see whether this is required or not. Maybe I will. This is actually slowing down the. I will close this OneNote because it is slowing down the entire PC. Okay. Okay, I got ARP. Okay, fine. ARP is important. I am planning to cover it in the thing. LAN 1, LAN 2 loop in STP, which is in session 4F. Is it? Is it in session 4F? Please tell me the exactly session so that I will open. Okay, I can't look for searching for it. Okay, okay. So must be here in this week. Okay. Okay, I'll keep it open, but I'm not saying that I'll cover that in that order. Okay. Anything else also we can do it. See, I have some guests at home. They are below, so I will try to finish as much possible. And then you guys, I don't want to take your time. Also, you have exam. 2 exams are there. So I will also be conscious about that time that I spend with you, as well as I have my own work on Sunday. So okay, fine. Lab 6. Okay, that anyway I'm going to cover. Now let us get into the discussion now quickly. Okay, don't waste. I don't want to waste time. Doubt clearance. Let me close this chat window. Is disturbing. I hope all people have joined. Okay, I don't know whether to minimize the whole thing or not, but anyway, let it be there. Okay, so let me explain here. This is a very old story about RS-232. See what exactly this thing mean. Start. Okay, um, is a short bit. Okay, it is all given in bits. So this is going to be 1 bit wide. Okay, when I say 1 bit wide, how do you decide the width of the width means in terms of time? Okay, how do you decide the width of the values going on the serial line? We decide it based on the baud rate. Okay, if baud rate is very high, then it is going to take a small amount of time. It is going to be 0 or 1. Okay, 1 bit width is going to be decided based on the baud rate. Higher the baud rate, lower the width of this particular pulse coming. Okay, that we are not going to bother about the baud rate, so you don't have to worry about the width now. Okay, so this is going to be 1 bit wide, and it is there is no optional thing. Okay, it is has to be there. Start bit has to be there. So before any data is sent, there is a idle state, the line between the TXD and RXD. See, suppose this is a sender, this is a sender, and this is a receiver. We are connecting TXD to RXD of this. Okay, and then RXD of this to TXD. Okay, now we are trying to send a data from one end to the other end. So it is going to somebody is going to send the pulse, either it is from this direction or this direction, doesn't matter. We are only thinking about one data flowing through this line. That time, during that time, one guy is one device is the transmitter, another device is the receiver. Now as per the standard, it is supposed to, it is normally the line is idle when there is no communication happening between them. One thing you have to understand, that TX is somewhere, Rx is somewhere. They have not talked to each other prior to it, or even during the transmission, or after it. What they see is only what is coming on the line. Okay, so what happens is transmitter is configured with some data, okay, based on whatever you decide, parity, stop bit, short bit, and the TRX is also configured with something. Now it is the responsibility of the user who is connecting these two devices with a serial line to make sure that these two are configured according to the uh, they are matching with each other. Okay, that's why some of the examples I showed you, if suppose there is a mismatch, what will be happening? Because when they are not matched, they think that the receiver thinks that this is how the data is coming on this line. Transmitter is supposed to generate the data bits based on whatever configuration it is asked to generate. So they don't talk to each other apart from whatever they see on the line. That you have to have a clarity on that. Okay, so now looking again, okay, one second. This guy is disturbing me. Let me move it. This interface is sickening. Okay, erase all. So now this is has to be 1 bit. There is no option. Now data can be 5 to 9 bits. So I may give you either 5-bit data or 6-bit data, or I can give up to 9-bit data, right? It can be that many number of data bits. Then after the data bits are sent, parity can be optional. When I say 0, you are not going to send parity at all. You can decide not to send the parity, or I can send 1-bit parity, or I can send 2-bit parity. That means what? 2-bit wide parity. Okay, at least for our sake, I am going to say 1-bit parity, and you don't have to worry about this. But I am trying to explain you what it means by 0 to 1. Okay, 2-bit is not there. Sorry, or 0 or 1-bit. Okay, this is only 0 or 1-bit. There is no 2-bit. I'm sorry. So either it will be a 0-bit. That means parity is not at all there. That's why while sending sometime I may decide to have 0 bit of parity. That means there is no parity bit sent along with the data. Okay, and stop bit can be optional. Again, it is not optional that you can have a 0. That means stop bit has to be there for sure, but it can be 1-bit wide or 2-bit wide. Okay, this is what it means, that 1 not 2. So when I say configuration on the transmit side, I am going to tell you the configuration on the transmitter side and going to give you some data bit, some data value. Okay, what are I am going to give? Data value, and then how wide it is, width of the data, and then anyway I have no option to say whether start bit is there or not. It has to be there. Stop bit I may say that okay, 1 bit of parity. Again, in this parity I have an option, odd parity or even parity. Now when I say that the transmitter is assuming odd parity, then what does it do? It has been explained in DSCA also. It just looks at the number of ones in the data. Either it is 5-bit or 6-bit or whatever, number of ones in the data. Okay, that number of ones plus the parity bit. That also has to be a 1. If one value, all together it should be either odd number of ones or even number of ones based on what you choose. So for example, suppose I say 5-bit data. Then what is the data? 0, 1, 1, 0, 1, 0. Suppose this is the 5-bit data I am planning to send from transmitter. And then I say that parity is 1 bit wide. Okay, it is anyway 1 bit wide only normally. And then I say that it is even parity, suppose. Now you are, when I say parity has to be 1, because I am not saying 0, that means parity has to be generated. Now this is the LS bit. Okay, when I am giving the value, I will say 0B. Then this is the MS bit, this is LS bit. Okay, small b. Now I have also told you that when it is sending the data on the line, it is going to send this bit first, then this, and this is the order it is going to send. Okay, so remember that's how the data is going to be sent from LS bit side. Now since you have said that 5 bits are going to be there, I have drawn how many? 4 plus 2, 6 I have drawn. So let me remove this 5-bit data. Okay, now it is going to send 0, 1, 0, 1, 1. This is the order, this is the time it is going to send it. You have to now draw this 0 either as plus or minus, you know that. Okay, as we have already mentioned that 1 means negative value, 0 means positive value. So this is some positive 12 volt. Suppose I say plus 12 volt, positive 12 volts. Then you say negative means 1 has to be negative 12 volts. So you will say minus 12 volts. Like that you will be drawing the waveform. Based on what you do, first read the value 0xb, then make sure that it is LSB is written first. So you are supposed to send out 0 first, 1 next, then 0, 1, 1. And then I am saying parity is even. Then what do you do? Number of ones you calculate. Then there are 3 ones are there. That means parity bit has to come here, which is coming at the, after the data is sent, parity is going to come. So parity bit in this place you have to make 1. You have to generate the waveform which corresponds to a 1 value, that means minus 12. So you have to draw a negative pulse here, okay, negative value. Then stop bit is what? Always it is value is 1, okay, whereas start bit is always 0, okay, that is, this is why it is high. And then stop bit is always going to be 1, and I may say that stop bit is only 1, then you generate the value of 0 also here. So to summarize, look at the data value, whether I am asking you 5 bit, 6 bit or whatever, then write it in the LS bit order, LS bit first and then MS bit next, and then look at the parity that I have given, whether it is even or odd, then generate the parity bit based on whether number of ones in the data is either 0 or 1. Number of ones are odd or even. If it is already odd number of ones, you have to generate 0, whatever. Okay, I hope it is clear to you. Okay, now let me explain it with the this example which is there right now. Okay, I am going to erase it. Now let me example here. Okay, I don't know whether, okay, can you reconstruct this from here? Okay, now let us understand it. Start bit, it is actually 1 bit wide, yes, and it is supposed to be always a value of 0. Okay, in binary value it is 0, so it is, we are giving a plus 15 volt. So this is taken care of. This is going to be always fixed. Okay, there is no doubt about it. Short bit will always be a binary value of 0 which corresponds to a plus 15 volts. Done. Now what about the stop value? Stop bit value, it is going to be a value of 1 because it is minus 15 volt. This could be minus 15 or plus 12 or 15. You can, based on the question paper, you can write it. And then this is going to be like this. Now what you have to do, you have to decide what, okay, from here to here, you have to decide because parity is going to be here. Okay. Now what is this? This is going to be the parity bit. Now data value is how many bits it is going to, it is sending 1 2 3 4 5 6. It is sending a 6 bit value, data bit value. Data bits are 6 here, and then I told you that this is LS bit and this is MS bit. Now then can you read it in a proper way? Suppose if I have given you a value like this, LS bit would have been here 1 0 1 1 1 1 0 1. Okay, 0 1. That means it is 6 bit data is correct. This is what I would have given you, 0x101101. Now you are trying to send the 1 first, then 0 next, then 2 ones you are sending 0 1. How do you send it? You know the encoding. Okay, you will say, put a negative value for a 1 binary value and positive voltage for a 0 value. Okay, you are taken care of sending the data bit. Now you have to compute the value of the parity based on what I would have given you. Now in this case it says is 0. That means what? If you count the number of ones along with the parity bit, 1 2 3 4, 4 ones are there and parity bit happens to be 0. Okay, in that case then it must be even parity. Okay, it is even parity. I would have given even parity, and then I have given that 0 is a thing. Okay, so that's why it is become 0 because data values are already even number of ones are there. So you parity bit you have to generate a 0 value which is being done. That's all about this. This is sure to come, and this is what you are supposed to do. Is there any doubts on this particular explanation so far? Okay, 0b, not 0x, right? Yes, I hope you guys know C convention is 0x is x, a value, and sorry, I don't know O, I think I have written O. 0x in the printf, what you say, it is hexadecimal, and 0b is a binary representation. Okay. Uh, okay. Fine. Any doubts from anyone? Can I say that, assume that there is no doubt about this? Already I have explained it in the earlier video, but I am doing it again, taking some time off. Okay. So, sir, in what condition will the stop bit be 2 bits while? It is depending on, okay, thank you, Smaran. Karmishta, okay. When will it be 2? If I say that stop bit is 2, if I say that, assume that stop bits are 2 bits wide, then what do you do? Very simple. Extend this guy to one more and then say idle. That's all. Okay. One more. You can show some dotted line to show that, okay, you are writing 2 stop bits and then idle. Idle is also same. This is what will happen. Okay. Any questions? This is a very very old story. I want to actually run to networking. Okay, this is also networking, but I want you to know how encoding happens at this level, bit level. Okay, I assume that it is understood. Now what is CSMA CD? Anybody expand it? Can someone expand the CSMA? What is CSMA?
So carrier sends multiple addressing and
Multiple access. Okay, carrier sense. Yeah, yeah, thank you. Carrier sense multiple access. Okay, CSMA. There is a reason why I am doing it. Multiple spelling is wrong. Okay, no, I don't know what it wants. Okay, and then what is CD?
it's a collision detector.
Very good. So let me briefly explain what it means. Okay, see, earlier Ethernet was actually a broadcast medium. Earlier means when the standard was defined. Okay, it's a broadcast medium. That means all the hosts were connected directly to the cable. Okay, and host 1, host 2. When I say directly connected, mean there is a Ethernet card. Okay, all of no, some of you might have used it. Network card. It was directly connected to a copper wire. Okay, so electrical signal was going on this. Now, what happens if you are sending one single line? Two people are communicating. Okay, they are what I am saying is two people communicate means one is sending, another is receiving. Okay, please remember, one is sending and one is receiving. One is driving the line with the values like whatever I showed you in RS232. Other host is reading it. Now, is it only one? Is it a one point to point contact? No, actually, it is a broadcast medium. So, whatever, suppose if I say this guy is transmitting and then there are multiple hosts connected. Okay. Now, when one is transmitting, it may be in the Ethernet address itself, MAC address is there, which is destination MAC address. It will have given the 48-bit values of the destination MAC it is trying to address when it is sending the packet. So, yes, sorry, frame. Okay. So, the frame itself is what consists of bits, right? When I say initially preamble is there, I will come to that anyway. Preamble, then SFD, then MAC addresses, and then the data. So everything you can say converted into ones and zeros, isn't it? Nothing more than ones and zeros is going on the line. Now, like RS232, I am not saying whether it is going to follow the same encoding business. Here the encoding may be different, whether 0 can be some voltage or 1 can be some voltage. We are not going to the details of it. So somehow Ethernet has decided that I will send the 1 at some voltage level, 0 at some voltage level, and it will be sending it. Now this signal, whatever one person is sending, it will send the entire frame, whatever is supposed to be, and it will stop. After that, it will be idle. So when this transmission is happening, all these hosts which are connected will be reading it, will be sampling it. Now they will look at the value. So because they all of them know the format of Ethernet, that's why I'm asking you also to mug it up, because that is fixed. Ethernet header is fixed. So all the headers, all the hosts which are reading these bits also will know when the Ethernet frame has started and where is the destination field, where is the source MAC address, all that it will read, and then it will check its own MAC address, it will check whether what is this sender is sending, addressing a MAC address is same as mine or not. Every host will be doing it. When I am calling some USN number, all your brain will work on and whether is that USN number is referring to my number or somebody else number, right? All of you are reading it. So let me read that later. One second. Uh, who is asking? Smaran. Okay, one second. I will come to you. So all the host devices will read the MAC addresses, and if it is supposed to be meant for it, then it will take the data in. When I say take the data in means it will pass it up to the protocol stack. No, IP layer will get it. Okay, Ethernet layer will check whether the value is received properly or not. CRC checksum is okay or not. Frame is properly received. Then it will send it to the IP layer, and IP layer will process the IP packet and further down. Okay, it will go up. Now, suppose if it is not meant for it, it will ignore it. Okay, it's not meant for me. So whoever is been addressed will be reading it. Suppose if you are sending a MAC address, destination MAC address, which is not matching with any of the hosts, that frame will be lost. It will not be read by anybody or no action will be taken. That's what I mean by sending data over the packet. Sorry, Ethernet frame. Now, what is happening in this CSMA CD? Let me explain briefly. Okay. So when I am saying that this line is broadcast medium, any data sent over it will be received by anybody, and then they don't know when a particular person is interested in sending the data, because it's like a phone lines available like intercom. You can pick up any intercom phone and then call somebody else in the hotel, right? So if someone else is also calling in this telecom case, it is very easy. They will not collide, but here, what will happen is if one device is sending a data, other device also checks that the line is free and then sends the data. Both data will be colliding. Okay, the signal will get overlapped. So you remember this is all working in gigabits per second, and any other interruption in the during the transmission will disturb the whole garbled data only will be received by both party will receive the garbled data. So what will happen is the collision will happen anywhere the signal is flowing, and then they will collide means they overlap with each other, and all the hosts in the network will see the collided signal. Okay, which is like a is like mixing sambar and curd together and feeding you. Okay, so when it happens, when you taste it, you know that it's not either sambar nor a curd. Then you raise a point that okay, I will not take it anymore. I will drop it. So don't think that this mixing of data will remain there. Once they realize it, both of them when they are sending the data, they will also be checking what is being happening on the line. So I put this guy puts a sambar here and this guy puts a curd there, but they read back sambar and curd together. That means there is something happening on the line. Then what they do, they back off, and it's called they back off for some time, and then for a random time period, and then one of the hosts will try to send it again. Now the question is, what will happen to the frame which got collided? Because the sender knows that the frame got garbled on the way. It knows that it has not been received by the receiver, even if the receiver is available on the network. So it is supposed to take care of sending it again whenever it gets a chance to again do it. Okay. So random backup they do again. They try to each of the hosts will try to send their packet on their own, and because they are doing a random time frame, they may not come back to the line again looking for sending the data at the same time. So they will send it. Now you may wonder what happens when two are communicating. Suppose collision may not happen. When they send it together, collision happens. But if one is already communicating, then the other person trying to send data will look at the line. If it is already busy, it knows that there is something flowing, so it will not disturb, it will wait, okay, till the communication stops. That is why the Ethernet frames are limited by number of 1500 or whatever I told you, because one person cannot hog this broadcast line forever, sending some 20 kilobytes or no bits or whatever data continuously. So everybody will get an equal chance to share the medium. Okay, that's why it's called broadcast medium, and this is what happens. Okay, any other questions so far? I hope I feel that I will stop here about the CSMA CD unless you have some doubts. Okay, let me look at what chat came here. You are only sending the messages to me. Messages are only addressed to me. Yes, I hope you are talking about Ethernet. Maybe you would like to send it to everyone. Oh, sorry. I thought you were talking about. Okay, how do I all you have to do a broadcast group chat? Okay, uh, everyone is there. Thanks, Maran. I hope you will be seeing the screen, right? Anyway, even if I am replying, people will be seeing the screen. That's what I thought. Okay, anyway, meeting group chat. Is it going to everyone? Okay, all I think. Meeting group chat. Okay, thanks, Maran. Okay, fine. Again you came. Okay, don't come. Okay, let me keep it in group chat. Okay, no problem. If anybody having any doubt, please come back. Okay, let me assume that you guys understood this. So let me go back further. Okay, to save time. And this all you can read it. Okay, fine. Now this is very important, guys. Okay, I don't have to stress upon further. Let me explain. There are three devices I have been talking about, which is on Ethernet. Okay, a level hub, bridge, switch. Okay, now what are they? Hub is a dumb, okay, dumb guy. It doesn't have intelligence. It does it whatever it receives, it puts it on all of them. So let me give an example. What do? You connect multiple hosts. You can connect it to anything. Please remember, I can decide to connect the host to either a hub or a bridge or a switch. Okay, as long as I want to connect a host to an Ethernet network, I have three devices to connect to. It's like you may have different plug points in your home, and you want to connect your laptop to one of them. Is You can connect it to any, right? Either a five, maybe 5 amp plug or 3 amp plug, or maybe a multi adapter or a 2 pin adapter, whatever. Okay, anywhere you will get the power from, right? Similarly, you can get connected to any of them. Okay, now the question is, why are you choosing one among the other? Again, I leave it to you. It is the I have at home one hub, I have one bridge. Okay, it's not that I have it at home and I am using it. I may intentionally connect it for some purpose also. Okay, wherever I want to have some no devices where I don't bother about having intelligence here. Okay, the thing is, cost of hub naturally will be lower than the cost of a switch. Okay, intelligence is there, you have to pay for intelligence, right? So when you are worried, when you are not bothered about having a switch, I am okay to have a hub. Now when you say I am okay to have a hub, I don't have money to buy a switch to connect all the four or five hosts, but I am willing to connect to hub. Now, are you sacrificing something by connecting to hub? Of course yes, because you are using a broadcast medium here. That means whatever you are sending is going to be shared by everybody is going to see a lot of when one is sending, other person cannot send. Okay, all those things happening, right? It is similar to whatever I explained you just now, CSMA city business. Okay, so when you have a hub, the suppose you are having a bandwidth of some 1 gbps line, it is going to be shared by all the hosts in the hub, because they are sharing the same medium here, and there is no intelligence in the device, and it is going to put you all in the one single uh, medium. So that's a sacrifice you are willing to give when you are using hub. Now when do you use a bridge? Suppose you have two networks, two different LAN. Again, when I say LAN means it's all network ID is common, it's the same, and the host ID is this. I hope everybody is aware of what is network ID and host ID. Suppose if I have a 255.255, this at least 0.0. Okay, whenever we are using the RVU yeah, IP address, if you see, it will say it will start with 172.16 if I remember correctly. So that's a standard for this higher two nibbles being network ID, okay, net ID, and then the other two halves of bytes are host ID. That means what? When I have such a network, I can have 2 to the power Okay, it is not exactly 2 to the power 16 minus 2 and all that. On the network ID side, there is a lot of limitation is there on using all of the bit pattern for a network ID, but approximately I'm saying this many networks I can have of this type. Okay, and then on the host is, suppose if I have one combination, see 172.16 is one network, 172.15 is another network. Okay, they are totally different two LANs. Now I may have a host with a 0.1, 0.2 or 10.5 or 100.2. See, always remember the numbers cannot be more than 255. Okay, each of the line, and 255 cannot be used as a host ID because that is a broadcast addresses. So the number of bits you reserve for host is 16 bit. Anyway, we'll come into the details in the after midterm, so I am not going to explain further. Please bear with me, because it is if somebody is not able to understand, I am not expecting you to know it, but it is going to be covered in detail after midterm. Okay, because some subnet mask is being used in all our Cisco packet tracer experiments. I am explaining it. So host ID can be anything that you can have in the network. Okay, so that will be 2 power 16 minus 2, because all zeros of host ID is not a valid host ID, because it's like USN number 0, is it a valid number? No, right? USN number starts with 1, so USN 0 is not a valid USN number, so it is also true with the host ID. Now all ones of this is also not a valid host ID, because it is expected to be a broadcast. Okay, Ethernet MAC address, you said, we remember Ethernet MAC, Ethernet uh, broadcast MAC address is, okay, destination MAC happens to be all one, FFF. Okay, 42 ones, 48 ones are there, then it means that it is a broadcast in the Ethernet medium. Okay, uh, remember that is in the Ethernet medium. Again, the same philosophy is there at the IP level. Okay, in the LAN network, if I want to send it to all the hosts, I can say that the IP address, if I say, well, I am trying to send it to 172.16. 255, okay, dot 255, suppose. Okay, 255 is all ones, right? This is the broadcast address of IP on this network. Okay, I am keeping the host ID as 111. Okay, just it's not relevant to any examination or something, as just I am explaining you as a, I'm always keeping it in mind that it is not exam oriented. Please think it is only to improve your knowledge on certain things. Okay, now Akshat has a question. Can all the other devices which are receiving the packet through the hub accept the packet even if it was not meant to them? No, they accept it. That means they read it, but they are not going to take any action. Okay, unless it is a broadcast packet that they have to operate on or they have to take action on. Otherwise, they are going to ignore it. Okay, it is received. That's what I am saying when I say broadcast. Okay, and then for example, packet is okay. Even if okay, what is that? Okay, well, a packet is meant to be sent to. Okay, why this fellow is blocking me? Okay, for example, if one packet is meant to be sent to PC0, can laptop 0 and server 0 read the data of that packet, since they are, yes, yes, they can receive it. They actually they can snoop on it. Okay, because it is delivered to them. Okay, and they may not. If they are very genuine guy and not illegally sitting there, they will not take any action. Okay. Now, what is the one more new message? Get it. Okay. Now let me come back. So if at all I ask you, okay, this is some IP address, okay, um, some IP address 168 dot 10 dot 5, okay. Okay, 1 second. Okay, so now, and all of them are okay. You do not have to now think twice that everything is going to be 1.8 1 dot 68 dot 10 something. Okay, it should not be same. Okay, the values cannot be same, the host ID cannot be same, but remaining, this is same. Okay, is this slash 24 notation, which is 255.255. You would have seen it in Cisco packet tracer. This is a subnet mask. That means this much is reserved for host ID if I am saying 192, and then this is only the lower ls byte is reserved for host ID. That means what, in this network 254 host devices can be connected. Okay, that's what it means, because two addresses are reserved, 00 is not used and 11 is not used. Okay, fine. Now what I am trying to tell you is, suppose if I am I don't bother about the Ethernet addresses or IP addresses. Suppose I am pinging from this device. I ping this one, server one. Okay, I do a ping. Now ping is one example. Otherwise I may say that some network traffic, okay, is actually going between these two hosts. Okay, they are talking to each other. Either do a file transfer is happening, or this is a web server. So this host has opened a web page on this server, which is hosted on this server. So there is a communication, one-on-one communication happening between these two hosts. Okay, traffic between these two. Now my question is, will this traffic, whatever traffic means, please remember the traffic is finally means some set of some Ethernet frames going across between them. Some frames will be traveling in this direction, some frames will be traveling in this direction. Okay. Now, where all this traffic is going to be seen? That's my question. Okay. Now, for a moment, don't bother about the sniffers here. Okay. Okay, let us talk about it later on. Right now I am not going to talk about the sniffers. Okay, let us ignore all the sniffers. Now this is a hub. Okay, so any data coming from PC0 will also go here, correct? Got it. Now what about this? This same traffic I am talking about, some packet A. Okay, some frame A is coming. Now the frame A is coming here, because hub is going to send it to all of them. It is sending here, here, as well as here. Now what does the bridge do? Bridge will only send across the traffic only the A, which is a frame meant for some host on this side. Remember, some host on this side. How does it know? It knows the MAC address. I assume that the all the devices, the bridges and switches, which are intelligent devices in the network, has learnt about the locations of where those devices are there, which MAC addresses are where, which side of the bridge. So a forwarding table I have already explained to you. It is already initialized. So if it is seeing a frame A meant for this particular server, then it is going to allow that to flow. So A will come here. Got it? I hope till that point you guys are getting it. A is coming from here, some communication, and hub is going to put it on all of them. So you have to trace it like that. And bridge is going to be intelligent to check whether it is to be sent across this or not. If it is to be sent, yes, it is going to send it across. Now switch is also intelligent. Now it is more intelligent than the bridge. That means it has got many ports. With the bridge, at least I am assuming that it has two ports here, but in the STP we assume that bridge is also synonymous switch. You know, a bridge also can be considered as a multiple ports are there. In that case, they are intelligent. Okay, they learn. Okay, which are the MAC address they are supposed to send. So when A is received by the switch on this port, it is going to check on which side I should send. It is not going to send it to all of them. It is not a hub. It is a switch. So it is going to send it only to this guy. Understood? So A will come here, A will come here, and A will come there. Okay, it is not going to be seen here. Now suppose A prime is the reply coming from this guy. Now A prime will come, it will be flowing here, A prime will come here. Bridge will again know that A prime is going to the PC0, which is on this side. So A prime in this direction will come here. But our friend hub is dumb. It is going to send A prime, A prime, A prime. That is what I am saying. So any traffic going is going to be seen by all of this on the host hub side, and on the switch side only the relevant devices, and on the bridge side only need basis it will be exchanged. Okay. So let me just look at the chat. Sir, switch also looks at the MAC address itself, right? Yes, switch also will. Remember, we are talking about Ethernet devices. All hub anyway doesn't look at anything. It looks at something is coming. It will send it on all of them. Whereas hub, bridge, and switches are looking at the MAC addresses. Can we use promiscuous mode to eavesdrop? Where eavesdrop, see, you can only eavesdrop provided something is given to you. You can be in a promiscuous mode here. Sorry. You can be on promiscuous mode on this side, and then you can eavesdrop. Suppose, take an example, you have two houses, okay. Let me draw two houses. Water supply is coming here, water supply is coming here. Suppose you happen to see this water supply also running by the side of you, okay. Maybe the neighbor's house water coming to you. Then maybe you can illegally put a hole, and then I'm not expecting you to do that, okay. You can put a hole and then try to tap that into you, okay. But if I say that pipes are not even coming to you unless you come to this guys and then put a cable there and pipe there and then illegally access it, you can't do a promiscuous mode. So let me explain what I mean by that. In ethernet scenario, otherwise water stealing only you will know, because Bangalore is going through a lot of water scarcity. I'm not teaching you to steal water from neighbors, but what I'm saying here, suppose A prime is coming here, A is also going here. How can this guy eavesdrop on this? It is not even coming to the laptop, right? A and A prime are not even seen here. So you cannot eavesdrop on something which is not even delivered to you. Switch is intelligent enough to not to send it to you. So it's not possible. Okay. Sir, hubs are okay. Hubs reads the frame or not, or it just detects some frame is coming. See, it has to read it, of course. Okay, it minimum things it will do. Okay, suppose garbled frame, it will not go and send it on all of them. Okay, I'm not saying dumb means it's not so dumb. It will read the frames and then send it on the other side. So of course, it will be reading the hub. Hubs also will be reading the frames, but it is not going to look into the MAC address and try to understand whether I should I send it or not. Okay, Avishi has a question. Sir, the switch will send it to all the devices in the LAN. No, it will send it only if it is a broadcast packet. Okay. So switch is, that's what I am saying. Okay, I think this picture has become so dirty. I should erase it everything. Okay, 1 second. Give me 1 second. Oh, ah, let me erase all of them. Start fresh. Let me make clear. One A is going. That A is coming here. Okay. This A is not sent here. Not sent here. Switch is okay. There is one caveat here. Okay, until that devices, who are these? Bridges and switches, learn about who is where, who is where. What I mean by that, initially, like all of us, when we are born, maybe through genes we got some knowledge, but still we start learning from abcd only, right? Even if you take next janma, we will start again abcd, not because we learned earlier in pura janma, then I should start from be or mtech or phd. No, you have to start from first standard. So when you switch on the system altogether, unless there are some mechanisms to keep the devices, cache already filled up and all that, we assume that all of them come like a baby born fresh without knowing anything about what is the network. So bridges also like that, switches are also like that. So to answer the question of Avishi, initially, until they learn where A is, they will send it to these people. Okay, I will in the exam I will clarify that they have learned. I will make it clear to you that all the devices have learned about the places of the host. Okay, after that we are trying to analyze what is happening. Okay, before they learn, they are like a hub only, because unless you tell the devices that which host is where, they are not going to be aware of it. Okay, so they will send it to all of them, and then finally they settle down, like our what happens in our spanning tree protocol also, because they are going to um, initially broadcast everything and then try to understand, learn about the system, about the devices, or what is there in the network, and going to learn from it. Okay, what about the destination address being all once for broadcast? Yes, if it is all once, switch doesn't have any say in it. Okay, I cannot say that I am intelligent, I will not send the broadcast. Oh, it is not intelligent, it is a non-compliance. Okay, if it is receiving a broadcast packet, broadcast frame, it is supposed to send it to all. Okay, during that time, maybe it's a good question for a, mcq, which I'm thinking now. If a broadcast medium, broadcast frame is sent, on a LAN, will there be any difference in the behavior of hub and a switch? Now I can say that no, hub and switch will behave the same. No, hub will only send the send it to all, but the switch will not send it. Multiple options I can give you, and then you have to cleverly choose that hub and switches will behave the same, because it's a broadcast packet. Even the bridge also will send it across, because if we are sending a broadcast, you are mentioning that I am interested in sending this to everybody in the network. So there is no intelligence coming into the play. Only when you are specifically addressing some MAC address, you have to bring your intelligence. Okay. So then until bridges and switches learn about the host MAC address, it cannot perform its job, right? Yes, you are right. Unless they learn, they will be dumb like a hub. Okay. Unless you learn, you cannot write in the exam. So similarly, unless the devices learn, they will behave like hubs. The intelligence part is gone. Okay. Is this okay so far? You understood about? Okay, now you may have a question that how do I know whether you are connecting a hub or a bridge or a switch in the network? I am going to show some picture. Actually, I have taken the picture from the packet tracer, and I have actually left the labels also intact, so that I am not expecting you to even memorize the bridges are low looking like this and all that. Okay, I am minimizing your memory cells, actually use of memory cells. I want it to be used for thinking rather than memorizing things. Okay, so I leave the no, sniffers are not, may not be there. I leave the, or maybe there, and bridges and hubs will have the labels there. Okay, I hope your eyesight is good. Please come with the specs. Some of you without specs like me can't read, so you will see those labels in the diagram which you can answer. So let me tell you, I am going to ask you to think a little bit in the exam based on what you learned here. Okay, that much I can give you a clue. So I am going to, generally I'm not going to know, I might ask you specific traffic pinging from one to the other. So one more thing, you may wonder how the traffic is generated. Traffic is generated by bridges and switches, maybe because of sending STP frame, right? Initially you know that STP frames are being broadcast, and then they converge, and then they still keep sending some STP packet. Apart from that, the traffic is due to the host. So if suppose if these two are communicating, some traffic will be flowing. Then I might ask you where all this traffic will go, which are the, where you will have more frames being sent across the LAN. That kind of questions I'll ask you. Okay, and then I may ask you to redesign a network uh, with something. Okay, so redesign means, not, don't think that I'm asking you to buy one switch or hub and connect them, but similarly in a picture, think about how do you optimize a network, like this line. Okay, just one question, not many, but it will make it interesting to you. Okay, so I'm not supposed to say more than that. Okay, why do we need a Ethernet hub when bridges can directly perform similar function? That's what I told you. No, who is asking? Okay, Karmishta. See, you are not willing to spend money for switches because switches are expensive, hubs are cheap, and then you are willing to live with the limitation of performance, because when one packet is sent, it is going to be sent on all of them. It is going to consume power. It is going to be, the data rate that you can gain from there is going to be poor. So hub is a low cost device. It's like you can buy a Maruti 800, or you can buy a a Ford Icon or whatever, right? So if you decide to buy a hub, you have to live with this limitation. That's all. Similar function while checking the MAC address rather than not broadcasting always. Yes, you can actually, better option to use the switches, right? Rather than hub. Bridges are a little. They do only, bridges are normally, in our case I am using it for dividing two networks. Okay. In I say one example I normally give it in the classes. You are having a, admin block, you are there, block, and then you have new building, and then you have incubation center. All of them have LAN, our LAN, RVU LAN, right? RVU LAN is there everywhere. You may even, I want you to go and check, actually. Go to the Wi-Fi of this building and this building and see, look at what IP address you are allotted. IP config you do on your, whenever you happen to take your mobile laptop to different building, just IP config you do and check what is IP address you get in each building. then you will know that okay, some set of IP addresses are used here, some are used here, some are used there. Now that means what individual LANs are there. They may have a Wi-Fi switcher, Wi-Fi router, or whatever. But how these two are connected? Because whenever you go, you are connected to RVU, right? So there may be bridges or some other devices. Okay, I'm not saying it needs to be bridge, but it could be anything. So I want you to think little bit about actually what is happening in the real network. Okay, basically we are building the network using this only. Okay, so I think 1 hour is over, so I should not spend too much time. Okay, I somebody said that I should talk about sniffer. Okay, now if I show you a sniffer, I will show the direction. Why the sniffer? It is a very specific to packet tracer. Okay, it's not that I don't know, C section guys have tried it out on sniffer. I have given you pkt file. You can always look at the sniffer and open the, click on it and then open GUI. Then you will see that it will see some packets flowing. Okay, it will show you the packet. Then you can click on the packet and look at the content. Okay, I'm not going to use the packet tracer now because it slows down the entire thing with the um, recording and other things were going on. I can explain you in case if you are not tried out sniffer at all. Please look at the lab pkt files I have shared. I'm sure lab 5 or lab 6 will have sniffer in it. Click on that, double click on it, then it will window will open, then tab GUI tab you open, then you will start seeing the whatever frames it is seeing. Now what will it see? That's what is the question that Amir wants me to explain. So there are a sniffer device is provided by our friend Cisco packet tracer guys. Okay, it's not looking like a sniffer, it looks like a helmet. It has a two port, Ethernet 0, Ethernet 1. Okay, now this is considered to be a input. This is considered to be a output. Okay, so when you connect sniffer to a Ethernet LAN, 0, if you suppose you happen to connect, assume that you are connected here. I say that this is Ethernet 0 and this side is Ethernet 1. That is what I have actually mentioned it by arrow. So what it means is, what you see in the GUI of this sniffer, you will see only the frames flowing in this direction. In this direction. Okay, I am not saying here. In this line. Okay, in this line, frames going in this direction. Please remember, all these lines are duplex. Okay, data flows in both direction. Always remember that data flows in both direction, but sniffers are connected such it only shows you this frames. It only shows you these frames. What about these frames going from replace going from there? Is it blocked? No, they are sent, but they are not captured and shown to you. This is a limitation on their simulator. Okay, they could have added one GUI, left to right GUI, right to left. If I was in Cisco and developing this Cisco packet tracer sniffer, maybe I would have put one more window saying that why don't you show both? Okay, connect a sniffer and then say left to right, right to left. Or, okay, it is little. We can even show A B and then A to B traffic is this, B to B A traffic is this, because anyway they will have all the information going. Okay, it's not that they don't know, but for some reason they have decided to put a sniffer only do it. Now how do I say both? If at all, if I ask you how do I connect a sniffer to see the traffic flowing in both directions? Okay, I want to do both directions. Can somebody tell me? I will give you one more sniffer. Okay, I want you to show me the traffic going here as well as here on sniffer. How will you connect the sniffer? Okay, let me chat window, let me go. Okay, let me answer all the questions by the time you guys think. But do real world sniffers capture packets in both directions? See, you have the real world sniffer in your home, in your own laptop, right? Wireshark we used, right? Wireshark captures everything. You can even do a filter on Wireshark and particular IP address you can look for, what you receive, what you send, everything is there. So real life sniffers are like this. Okay. Yes. ICMP. What is ICMP? I don't know what you are writing by ICMP. You are asking me to explain ICMP, or what is it, Dikshita? You want me to explain about ICMP? Can you? Yes sir. No. Yes sir. Okay. That. Okay. Fine. See. Okay, let me come back to it. Can anybody tell me how do you connect a sniffer so that I can see both the traffic on Cisco Packet Tracer? See, I have not done it myself. Okay, I am only asking you. I'm just getting this idea now. Okay, okay, no problem. I will tell. Do anybody want to try?
So we can try to connect port 0 and like reverse the connection basically. Like let's say you want the packets to like we want to know the packets flowing in both directions from switch 0 to server 1. Let's say for now.
Uh,
So we can add another sniffer in between
where
sniffer 3 and switch 0 and then connect server 1 to port 0 and switch 0 to port 1 of the sniffer.
very good, very good. That's what I said. So you can connect. See, let me explain. You have a sniffer here, another sniffer here. Okay, some device here, host one or switch one. Okay. Now what do you do here? Ethernet 0, here Ethernet 1. Let me call it as sniffer 1, sniffer 2. Now Ethernet 0 means okay, it is going to capture in this direction. Now what I do in this sniffer, I connect Ethernet 0 here, here Ethernet 1 there. It is going to send the traffic of this. Okay, that's why I think Cisco did not bother to uh, give it in one device. We are making you connect two devices, and GUI of this will show you all the traffic here. GUI on this device will show you all the traffic here. Okay, but actual packet going in both direction will go through the sniffer seamlessly. Okay, there is no, this is not going to block anything. Okay, I hope this is clear to you. Very good, Smaran. Okay, yeah, Sri Vaishnavi, very good. Maybe order port of server 1 can be connected to hub and hub to sniffer and then sniffer to switch. I don't know, Arya is also telling the same thing. Anyway, I hope I think I have explained it. Okay, now let me answer Dikshita's question. Okay, now what is ICMP? Okay, it is internet control messaging protocol, if I remember correctly. Okay, as I told you, please mug up all the whatever acronyms. Just this is very important, immediately on the interview, do you know ICMP? At least expansion, if you tell, at least the interviewer is happy with you, and then he'll ask you further more down until you say no. So what is ICMP? This is a separate application protocol. Okay, ping is a one of the commands which uses ICMP protocol. That means when I say something is a protocol, it has got its own header. Okay, its own header and its own payload format. Okay, what is supposed to be sent here? Okay, ARP is also one example. I will tell you that. Okay, I will come to that later. So ping is going to use this ICMP packet. Why? It is going to send. See, ping is on command. You are saying that this is going to ping this fellow. That means it is supposed to send the IP address of this. Okay, so it is a what is the intent? You are trying to send a packet, ping request to this device at the end. Now, till that point, it is going to come. Plus, when you send ping, ICMP is okay. Let me draw it properly. What is happening in the packet? Okay, header, Ethernet header. Okay, let me try to be little clean. Sangamesh told that my handwriting is bad. I agree. Header. Okay, Ethernet header, IP header, ICMP header. Okay, now this is going to have the payload, which is the ping information. What I want to ping. Now it is flowing from this guy. Okay, ping is coming. If you look at the OSI layer, ping is sitting on the top, then ICMP is down, then IP is there, and then Ethernet is there. So it is flowing from the OSI layer from top to bottom. So as they go down, the headers are getting added to the frame. Now when this finally Ethernet header with the entire thing is formed, the whole thing whatever you see here is the Ethernet payload. Okay, um, so this whole thing is going inside it. Now you are saying that IP address I am interested means this IP ping, suppose when you say ping 192.168.10.5, if you do that 10.5 will be sitting here as a destination IP address, and it will also say that it's a ping command. Please send a reply when you receive it. Okay, but whereas the Ethernet header portion will not have a IP address in it because it only understands the MAC addresses. Now it is supposed to have the destination MAC address. Okay, destination MAC address of which device? Can you tell me? Suppose if I am trying to ping 192.160.10.5 from this PC, I am interested in pinging this guy. Assume that this is 10.5. Now Ethernet is uh, created, Ethernet header is added, and it is supposed to fill it with some destination MAC address. Which destination MAC address should it put? Will it put a broadcast MAC address, or will it put a destination MAC address of this device? At least can somebody say yes or no? Or let me ask you, will it put 10.5 device? Avishi is saying yes, because it is not a broadcast packet. It is a ping to a particular guy. Okay, so that is going to be destination MAC address of our device. Now the question is, how will this sender knows about the MAC address of this guy? That is where ARP comes into play. Okay, maybe this is the right time when I can switch over to ARP and explain you. So let me breathe for a while. 1 second. Please have some water. Okay, so it's a very complex thing to understand. As the protocol packets get going down, each of the layers are going to be adding their own headers, and then finally they want to send it on the it's like a packing your material that you sent it to DHL, and then they pack it and put it on a ship or something to send it across the different continent. They pack it on one after the other, right? So here they pack from your own packet to into a Ethernet frame. Now when they send the Ethernet frame, they are supposed to fill the header with Ethernet MAC address. Now if they don't have it, if this device doesn't have it, it is supposed to find out what is the Ethernet MAC address. So that's where it will stop. Now when you want to ping it, it is not going to ping now if it doesn't have a MAC address. It is going to freeze that request for some time, trying to get the MAC address of the device. That's what will happen with the ARP. Okay, so I will park it there. I will come to ARP to get the MAC address. Okay, let me just say that it is going to run the ARP protocol to get the MAC address, and then once it gets the MAC address of this device, it is going to put that into the Ethernet frame and then send it across, so that this packet finally lands into the server. Okay, so any questions so far? I am actually running out of time. Any questions? Okay, fine. So I presume that you have understood the purpose of this and how to answer this question. Okay, all sections. I am, when I say you, I mean all. Okay, now all of you are on the same page for me, and all of you are in the same state also. Okay. Okay. Now forwarding, I quickly talk about it. See, these are all, I am calling it as a bridge or switch or whatever you call. They are having multiple ports. Okay, the hosts are connected, and when you are this is what is learning of a particular route. Okay, so when they are trying to learn, okay, some chat is there, let me see. So if the host doesn't know the recipient's MAC address, and ARP request will be sent to the okay. ARP address is sent to know the destination MAC address, and after that ping request will be sent. Yes. So ARP request is sent, and I will come to that ARP in another 2 minutes, few minutes. ARP request will be sent as a broadcast because it doesn't know it is in a LAN. Okay, and I assume that you are trying to ping some host which is in the same LAN. That means the network ID is same as your own network ID. Then it knows that it is somewhere in the LAN only, but it doesn't know where is it, whether it is this side of the bridge or that side of the bridge, or if where exactly, whether it is there or not, it doesn't know. So it will send a ARP request as a broadcast. Okay, then you know how to send a broadcast, right? You will put Ethernet MAC addresses all once, simple. Then any switch or anybody coming on the way, they will not filter out, they will send it to everybody. Then once they send it to everyone, they will all respond back, or not all of them will respond back, only because they will know ARP request is for a particular IP address. So the device which is having the IP address will only send back its own MAC address, okay, or reply. That will also be maybe a unicast or broadcast, but normally it is unicast, and it will come back to the sender, and the sender learns about the MAC address of the device. Okay, so that's how the whole thing happens. Okay, so any questions from anyone? Got it. Okay, fine. Forwarding of this, I think I should go fast now. Okay, so well, very simple. You have a destination MAC addresses. Okay, please always remember these are all MAC addresses. And based on the packet which is coming in or with the source MAC address, it learns them and it is filling up the port on which they are supposed to be sent. Okay, forwarding port. So once they are learned, they fill up the forwarding ports with the specific port addresses, and they will be forwarding to only those devices. Till that point, if the particular thing is not filled, they behave like a hub and they send it to everybody. Okay, that's what happens. Okay, fine. Now this is about forwarding table. Any questions you want me to explain? It's very simple. What happens is, when it is exchanging any packet through the switch, it looks at the source MAC address of the frames it is receiving, and it knows that somebody is sending from this source MAC address from this side. That means that MAC address is somewhere here on this port. So it will make that entry as for that particular MAC address. That is the port. Okay, that's what it learns from. If somebody is saying that my name is this and I am sending this frame on from this side, he know that it is on this side of the port, on that available on that port. Okay, see, it is available on that port doesn't mean that it is directly connected. It could be further down, but if I send it here, somehow it will reach that guy. Okay, that's what it actually means. Okay, fine. Now, any questions on this? Okay, let me. You guys read it. Okay, I was well explained. Now, here what I am saying is, we have a multiple switches are connected. Okay, and what is that coming? Chat. Datagram same as a packet. Datagram same as packet. Yes, datagram is same as a packet or a frame. Sometimes no, some different um, pictures show different things. Okay, so I don't want to edit everything, so I show packet. Okay, but actually, if you are on switch, it is actually a frame. Okay, a little bit people use it intermixing, mixing it. Okay, fine. Now there are multiple paths available in the what I have explained in this particular diagram is, there are I am fixing some no, I am having an algorithm where I have equal distance, that is number of switches on the way is like equal, then I may choose the lower port number, that way I connect it. I am not bothered about how it is getting filled. Okay, it is already fitting filled, and then um, as long as it is taking you to that particular host. Okay, you can actually, it's like a quiz only. By now you should have studied it. Now apart from this, there can be a default also. Okay, suppose always the network is supposed to recover from failures. So some link going down or some switch is going down, still you can connect through some wrong route any host, right? Even one switch goes, everybody can be connected. Okay, but multiple people, multiple switches, these two switches go, then you cannot do anything. But you can always recover from some failures, not all failures. In that case, how it is going to be routed. Okay, that's all. No, default ports are whatever port you are sending, particular thing, you choose the port which is not used in your forwarding table. That is what is called a default port. Briefly explain about circuit switching and packet switching and message switching. Oh my god, you want me to run the entire class, man? Okay, see, circuit switching is, I'll come to that. Okay, this is a datagram switching, or though what happens is the switching is happening at the, we are not reserving any particular path for it. Okay, okay, let me explain what you want me to explain. Source routing you are not asking. Okay, I will explaining you about circuit switching now. Okay, see, what you do is, this is packet switching here, or a datagram switching is, you don't fix a particular path. Okay, you don't fix a particular circuit for you to exchange between two. Okay, the a datagram can go through anything based on the forwarding table entries in each switches. It can flow through anything and reach it. Okay, that's what is called datagram switching. Okay, now that means you are not fixing a particular connection for the entire communication. So one datagram can take this path, and then imagine that this switch has gone bad. Then another datagram to the same source may reach it through this path. Okay, or whatever, if some switches failed, the default route is there, and somehow they will reach. Okay, this is how datagram switching happens, because datagram switching means the datagram or a packet or a frame has complete information about the destination, and the explanation is given in the slide, and I am just explaining you here. The each data, when it is going on the network, they have the complete information, okay, about how to go. You are not actually setting up anything before. You just drop the packet, expect it to go, best effort delivery. That is what is called datagram switching. Okay, in summary. Okay, now let me explain about this is actually explained. So let me go to virtual table. This is circuit switching. Now what is circuit switching? Let me move this guy up. This is a little complex. Okay, what you do, I am interested in sending a some, not only single packet, I want to send a stream of things. Okay, maybe some video streams or some live broadcast, something I want to do between host A and host B. Now what I want to do is, suppose I have multiple paths to reach host B. Here I am showing only one path, but for simplicity sake, normally no network will have only single path from one A to one host to another host. Okay, if it is spread across the entire continent or country or campus, so there will be multiple paths. But what I am trying to tell is, I want a fixed path of this for all the packet that I am sending should pass through these switches. Okay, and they should take this path. Now what are the steps you need to take? If you have to take, this is what is called a virtual circuit or circuit switching. Okay, that means what you are actually, like a wire you are taking and connecting it like this. Okay, fixed wire, and any packet datagram d1, any datagram d2, datagram d3, I send it afterwards, after I set up the circuit. All d1, d2, d3, okay, they all go through the same path, so there is no difference. Okay, whereas in datagram switching, what I explained you earlier, in between one switch can fail, and best effort traffic, it may reach here. Okay, d1 may reach here, d2 may reach through this, maybe d3 may come through this, anyway. Okay, they can take a different path in different ways. So that is possible in datagram switching, whereas in circuit switching you want to fix the path it is going to take. Now how are you going to achieve it? Unless I know the entire path, until I reach the host, I will not be able to do. So what is done is, each switches are going to maintain a virtual circuit table. I am saying VC table. Each is going to maintain a VC table. Now what are the entries in which table? It has got incoming VCI, outgoing VCI. VCI is a virtual circuit identifier, I think. Okay, identifier, some number. Okay, now let me explain what is happening here. Now okay, not erase it. Okay, now what is happening is, before you actually start sending data, you are setting up the circuit. Okay, you path. Now somehow you imagine that these switches are already knowledgeable to know which port they are supposed to send the connection setup message. Okay, you are sending a connection setup message. It's like a calling a number and then connecting to the other mobile number. That's the setup you are doing. After that you start talking. You cannot start talking before the connections is set up, right? Between one person A to B. So the connection setup is happening by sending a connection setup to say that I am interested in setting up a connection with the host B. Host A is sending. Now on the way, what happens is, there are some okay, what is chat is happening? Should a datagram package be connectionless always, or it can be no, also for traveling from source to source? No, a datagram means it is connectionless. Okay, so it will be, it can take any path. You are not fixing anything particular as path for it. Okay, so let me come back. Now when you want to do it, you want to this is one thing you remember: A to B connection, A to, okay, A to B, host A to host B is a one connection. Okay, one connection. Similarly, host B to host A will be another connection, another entry in the table. So every active connection between two hosts will, there will be one entry in the table. Okay, and on all the switches they go through, all the switches they travel through. In our case, there are three switches which are there in the path, so all of them will have an entry. Now each of the entries, we have, what is that we have to do? Incoming VCI you have to have, and outgoing VCI I said. Now initially when the host A is sending, it will say that, okay, host A is initially setting up, right? It will send some number, let me call it as um, x, y, z. Okay, it's like something like that. It will say that I am going to send you a pack datagram, I am sent a packet with the number x. Okay, some number x I am going to send it for a connection from host A to host B. Okay, for this connection I am going to use this particular incoming VCI. That is because it is going to send it. The person who is sending it is saying that I am going to use this incoming VCI. Okay, so this switch is going to create a entry with the X, saying that if I get from host A with the X as a packet with X in the header, then I am supposed to use that. I am going to map it to the one entry in the VC table. Now, what is going to be the outgoing interface? That number is anyway known. Outgoing interface is 1. But what is going to be a VCI? I am only interested in VCI. Now, VCI is something this device is going to tell I am going to use. Maybe I will say that, okay, let me call it as X1. Okay, X1. I am going to say X1 is what I am going to use. Then I am going to create a entry X1. Then X2 is going to be what I have to use to this device to have it as X2 here, one entry with the, see, this outgoing interface will be the same as incoming VCI here. Okay, and the intermediate switches. Okay, this X2 I am going to use it. Now that who is supposed to do, who is supposed to pick that X2? The responsibility is lying on the downstream switch. They have to give me a number which I should put it in outgoing. See, effectively what I am saying is between two links, whatever outgoing VCI I put it should be same as the incoming VCI in the entry there. One entry should be there with the same number as incoming VCI. That means then it will pick this value. Let me take x3. Then that will map to some x3 here. Okay, and that x3 will be on the 1. So this should be a connection. Okay, this incoming and outgoing are specific to a particular connection between two devices. Okay, so let me erase all of them now. If I erase it, you will lose everything, but I don't know what to do. Okay, some admit I will do. Any chat is there? Nothing. Okay, now I have to use different color maybe to more, not to make it dirty. Already it is dirty, but let me try to recover from it. Now I told you that this number, whatever I choose, okay, outgoing VCI I am going to put it. So when I am sending the packet, data packet, I am going to put x2 here. And this guy is expecting x2, then it will see x2, then it is going to replace that x2 with x3 there. And this guy is going to look at the x3 and it knows that this needs some y. I will put y in the packet and send it. Okay, so it will go there. Now, but how do I choose x2, x3, y? That has to be coming from the downstream devices. Okay, the downstream means it is data is going from A to B. This is called downstream. Something below, further down from A to B is what is called downstream. Now who will choose this y? What I am going to use, x3 is going to use this y, what is going to be used is chosen by host B. That means what? It is supposed to reply back saying that you have to send the connection request from here to here. It flows up to this point. Till that point you are not going to you know fill this entries there. Okay, and then while coming back, when you are assuring that, acknowledging that okay, I am willing to take this connection, it's like you are calling your friend, the other side mobile may ask you to may take your call or disconnect your call. So now the other person has accepted your call, then it is means that it is the person is willing to talk to you. So once this device accepts it, it is going to send a y. Please use this y when you send it to me. Okay, that's what you are telling. This host B is going to tell this immediate device, please use y when you send it to me, because I am deciding my incoming VCA what I need. Okay, the outgoing VCA is sent by this guy, that becomes incoming VCA here. So only one VCA will be sitting on the packet. Okay, one number will be sitting on the packet. So use this number. Y is chosen by host B. Now y is filled. X3 fills the y. Now sorry, this switch 3 fills the y. Now it choose x3. It choose x3 and then tells this guy, hey, when you are sending me, fill x3, because I have created a table with an entry x3 in my table. It doesn't inform about y. That is with the y is between the host B and the switch. It doesn't have to inform the switch 2. This is switch 2, this is switch 1. So it says that, hey, I have chosen x3, please use x3 when you send it to me. So outgoing VCA x3 is chosen. This guy chooses it, and then it chooses x2 here now. Okay, x2 is chosen by the switch 2 and informs this guy, hey, when you send me, please send x2 in the packet. So I will know that, oh, okay, you are talking about this particular entry in my VC table. Okay, now then it chooses x2. Now what happens, it is going back to this guy. Already it has chosen x1 from our friend host A. So it says that, okay, everything is fine, I have set up the entire connection, now send me the data packet. Now when the data packet comes, let me take another color. Sorry, I have to live with this multiple things there. Let me take another one color. Now imagine host A is sending a data. It will put the data here. Okay, whatever data, it will say x1. Okay, I am interested in sending this packet on this circuit link that you have created, or a switch circuit you have set up from A to B. Now once this incoming x1 VCI is there, it it uses that to index into the table, and then it picks up x2. Then another packet flowing here, sorry, I am drawing here. It will have x2, the same data is there, but x1 is replaced by x2 and sends it to this guy. Now x2 is indexed into this. Now it knows that, okay, I have got entry x2 with the one packet here, so I am supposed to replace it with x3 now. So let me now create another datagram. Not a no same datagram is used, same data is used. I will replace this x2 with x3. It goes there. Now x3, once it comes, this fellow knows, switch 3 knows that, okay, I this packet refers to this particular entry in the table. Now I should replace it to y. So I will send finally the packet to the host with y and the same datagram. So it goes there. Now effectively what I am trying to tell you is, each switch maintains one entry in the virtual circuit table to indicate a particular connection going through it. Why is it done this way? That can be elaborated in a long discussion. Many circuits can be going through this switch. There may be many circuits going through this, but it identifies every circuit using that ID. Why is it that, why is that choosing of this ID is given to that switch? Because that only knows the unique entries that it has to have. X1 it is choosing some other number, x11 should be different from x1. So each switch has to be having its own unique ID. Okay, that's why. I don't know how much you got it. I cannot explain it with so much of scribbling. But if you listen to the lecture and the scribbling, maybe you may understand it. Let me ask you: is this at least slightly make it green? Okay, G1 got it. At least from C section on guy got it. I don't know about A and B. I have explained multiple times. I don't know. Okay, Smaran also got it. Okay. Um, this is what I can explain, man. Before the exam and with this kind of a last minute preparation, let us not go deeper into it. Then now, if you read through it, you will be able to understand it. Okay, why acknowledgement is coming and the 7, 11, 5. See this 4, 7, 11 all belongs to that x1 x2 y I told you. Okay, if you see, they're all picked up by these guys. Okay, 4 is picked up by host, 7 is picked up by this guy, and 11 is picked up by this, and 5 is picked up by this guy. And no, actually initially, yeah, incoming VCI. Okay, then it sends it. Okay, I think 5 is no, no, 5 is going, but 7 only is coming actually. Incoming 5. Okay, 5 is chosen by this guy. Did I mention anything wrong here? No. I think Act 5, this guy is choosing that index and then sending it to you. Okay. Okay. Sorry, I think I mentioned the other way around. This switch also chooses its own ID and sends it to you. Okay. I hope this is clear. I presume now I quickly talk about STP and stop it. Okay. Chat to yes, got it understood. Okay, thank you. Shushan also said. Source routing is very simple, guys. You decide the entire path what you are going to do. What is this path? Actually, it refers to the switch numbers. Okay, 1 refers to this, 0 refers to this, and 3 refers to the port number, output port number where it should be sent. So this port numbers of output port numbers of switches they pass through. Okay, and when they go, every switch is going to rotate it so that it doesn't know how many hops it has come through, right? So if you rotate it and give it, it is easy for the switch to read what port it is supposed to send it. So it will send it, and then it will rotate it and send it, and this guy will send it on the port. So you can go on for anything. Okay, that's how source routing is decided a priori by okay, a priori by okay, pen I have to choose. Oh, sorry, one mistake. Okay, pen. Fine. Now, this is what I thought I will talk about ARP. I think this is a ARP. So I will complete that ARP business. See, suppose this device wants to. Is it ARP only? Yeah, ARP. Okay, let me look at the chat. Understood ARP. Okay, don't worry, I'm coming. Okay, so this is about ARP. So what is ARP? It is actually to translate IP address to a MAC address. Which MAC address? Destination MAC address. Now I know that I am supposed to ping this guy. Okay, suppose some in the command line you have sent this command. Sorry. This is the source IP address. Okay, this is the IP address of this device. I am trying to ping this guy or this guy. Okay, okay. Let me choose this guy. Okay, let me correct it. I am not trying to ping my own myself. Ping is I am trying to ping this guy. Okay, now what is happening? This is the IP address of this device. Okay, I am going to draw on this. Okay, please bear with me. I am going to I want to ping from this device with a 2 of 0.3. Now assume that this I have to create a Ethernet packet with a destination MAC address. I need to fill. Now I don't know the MAC address. Now what do? I have to find it. Now what should I do? I have to use the ARP protocol, which is the um, address resolution protocol. It's a separate packet will be there. Is that will be sent. It will have its own. It will be sent on an Ethernet frame, but ARP is sitting on top of it. Okay, so anybody will receiving will know that it is a ARP request. Okay, it is to start with, it is a ARP request, and then ARP response, I think. Okay, ARP response. Now when you send a ARP request, you don't know which is the host trying to having the MAC address. So what you do is, when you send a ARP request, you create a packet. Inside that you put the IP address of the device, which is whose MAC address you are interested. I am interested in 10.4. So this is going as a payload. Okay. This value is going as a payload because it is a ARP. It will know how to read that particular value from the packet. So it has to be sent as a ARP request is sent as a Ethernet for broadcast. Okay, broadcast. So it is sent to all of them, and then this device also receives it. When it receives it, it knows that it is addressed to me, and it knows the source MAC address. It knows, so and the source IP address also it will know. Then know that this device is interested in getting my MAC address for it to communicate with me. So let me learn its own MAC address. Okay, now it is learning about 10.2's MAC address, because source MAC address will be there in the MAC. Okay, please remember, always you are sending your own from address to address. So source MAC address is learned, source IP address is learned. So it will learn actually about the MAC address and IP address mapping. Okay, because the same IP packet also is there, so Ethernet packet is also there. Source MAC address is there in the Ethernet frame header, and source IP address is there in the IP header. So it can actually map it to its own ARP cache. It can fill it up. It will learn about 10.2. Now it has to inform its own MAC address, which is sending to a individual unicast packet. So ARP response goes, and keeping, it doesn't have to do anything special, because Ethernet frame itself has a destination MAC and source MAC, right? If you send it back, source MAC address will actually refer to the MAC address of this device. So this guy will learn about it. It is very logically, if you think, I am asking, hey, anybody having this IP address, please send me your MAC address. Then whoever has it, everybody receives it. Whoever has that IP address, they know what is they are configured to. They will send back reply saying that this is my MAC address, and later on the communication happens between them. That's all is about ARP. Any questions on this? What is the time? Yeah.
Sir, let's say when PC0 sends an ARP request to, let's say the PC laptop zero's IP address.
Hmm.
So in
No,
that case,
wait. It mentioned that I am interested in knowing the MAC address of this IP address, but the Ethernet frame goes to everybody. It's not one specific. See, IP address. If you say, then it will be only specific to this guy. So it is actually saying my own IP address is so and so. I am interested in knowing the. See, actually, what will happen is IP packet may not be sitting also. ARP packet will be sitting inside. Okay, directly Ethernet header and ARP packet will be sitting. Okay, are you getting?
oh, okay, sir. So, and this, when PC0 sends an ARP request, the switch one would send the ARP request to every other PC
Yes,
and broadcast.
yes, because it is a Ethernet broadcast, right? It will not use its intelligence. It is supposed to send it to everybody. It will treat the broadcast frames differently than the unicast frames.
Okay, sir. So in that case, then server 0 and PC1 would also learn that
Yes, yes,
this this MAC address associates to this IP address for PC0.
yes. Actually, when this ARP request goes to everybody, all of them can update their ARP cache. Okay, you are right. They can learn, because the source MAC address is there of this device, and its own IP address is there. Okay, so it will not know the MAC address of this until the reply comes. That reply also, sometimes it is sent as a broadcast. Okay, reply also is sent as a broadcast, so everybody can learn. Okay, so that suppose if this guy wants to learn again, it will send a request, right? It's a unnecessary load on the frame Ethernet. So it may even send the reply also as a broadcast, so that everybody learns. So remember, if the broadcast packets are sent, everybody receives it, and they can take any information from it. Understood?
Yes, sir.
Okay. Is the IP address padded to the destination address table? It's like a draw the source and destination address table. Now, what is that? No, you have to explain in words. You don't, because you don't know the. I have not explained you the packet format and all that. You just express it in words. It's okay. 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 What is the time? I don't know. Okay, another 10 minutes. So, any questions on this? Okay, let me now. Aha, we have come to the final stage. I explained it in both A and B. Do you want me to explain C section? ARP request is always broadcast. Don't say ARP is always broadcast, ARP request. So, okay. And then when PC1 receives the ARP request from PC0, PC1 will store the MAC address of the PC0, yes, in ARP cache, and sends the ARP response to PC1 MAC address from PC1 back to PC0, yes. Who is that? Arya. Yes, you are right. See, always you try to extract whatever you can, okay? And similarly, all the devices in the network also are intelligent. Try to make best use of what is happening, because they will update their ARP cache inside, okay? Because you don't know later on, it's like this, no? On the way, when you see somebody, better you don't snare at the guy, or say hi to him, okay? You don't know when you need the help from that person, right? Always they say don't burn the bridge. You never know whom you are going to again end up communicating. Similarly, all the devices are there. They are anyway PC0 and PC1 are talking, but maybe I may have to, we don't know, my user who is sitting on top of me may be interested in communicating with the device. So let me take the what I learn. It's like this: when you Google and find out something, always keep learning. Okay, that's what the devices do. That's what I want you also to do. So art request is just to identify and locate the addresses of the devices, right? Addresses means MAC addresses. Okay, be specific. Okay, don't say address. Address means it can be a postal address of the device where it is. Okay, RVU, Mysore Road, all that. Okay, okay, fine. Now final guys, 10 marks. Sorry, not 10 marks, 10 minutes. Okay, don't tell me that Mowli said 10 marks and I want 10 marks. Okay, see, when I give this picture, no dotted line will be there, all solid line, but thick line will not be there. The thin line like this will be there. Okay, such lines will be there. Now I leave it to you. Okay, one thing I want to announce it. I don't know whether I can do it now. 66 participants only there. I want the question paper to be kept along with the answer book. Do not take it away. And if you want, you can write the answers on this, because drawing this whole picture will take time. But if you are editing it, it's a problem. So make sure that you have eraser and other things to do it. Now, suppose if I say that this bridge is named as B1, or and this is B1, sorry, B7 and B1. That means I swap these two bridges. Okay, now always remember the STP algorithm thinks who is going to be the root node. It decides based on the lowest bridge ID that there or MAC address or something. When I am calling it as a bridge ID, it can be specific to a particular MAC address of the device or something. Okay, but don't bother about those things. They are identifier of that particular device, bridge device. Okay, and that is what is going to be used. There is nothing called MAC or something. It's an identifier. Okay, don't get confused. So now suppose if I have it, what will be this STP? Now STP algorithm I already explained. I'm not going to explain again. So what do you do? B1 is going to be root. So you have to connect all the LANs which are already closer to it to the bridge, right? This is RB. Okay, I naturally will connect all the LANs which are directly connected. You can actually be connected to B1. I don't need to put a dotted line here. Done. Now look at one by one. You try to see what is the path they are supposed to take. Now look at B5. B5 is one hop away from bridge B1. Now it is actually having a path. Okay, like this as well as like this. Okay, let me draw it very lightly. In that case, what will happen? This is actually after one bridge it is reaching, whereas it is directly reaching, which is shortest. This is the shortest. So naturally you have to connect this STP. Okay, always every bridge is trying to see what is the motivation behind the bridges. See, bridges as such, they are not going to send anything. Okay, actually the each LAN is going to be deciding. Okay, let me actually come from the LAN, which is logical enough than trying to bridges as such. They are not connected, interested in connecting. Okay, actually I am sorry, I should not even say bridges are interested in connecting. Why should bridges be bothered? Okay, they are not interested in sending anything unless the routers are LANs are. Now let me say, look at A. Okay, now sorry, please reset again. Now B5 is not going to decide. A is going to see how do I actually speaking, you are thinking in the perspective of A. Actually the jobs are done by B1 and B3 by exchanging information. Okay, so for you to be clear about how to draw it, I am asking you to think from the perspective of A and B and C and D. Okay, it is our own perspective. But actually who is doing the job? Bridges are doing the job. How are they doing the job? They exchange information and then try to find the path. Okay, but now I am giving you a shortcut path to do the same thing. Now let us look at A can reach through B5 or B3, B2, B7. Naturally through B5 coming is better. So then only this is hardened. Okay, you have to make it into a dark line only from the perspective of A. Okay, when you do it. Okay, fine. A is taken care of. Now you don't worry about B3 now. Okay, leave it. Now come to C. Okay, you can come anywhere. Okay, let us come to D. Okay, which is closer, right? Why do you want to go further? Now, how will D reach B1? D can reach through B7 and it can reach through B5 also. Okay, both are actually equidistant. Now the tie will come. type says that lower bridge id you choose. Okay, so darkening this has to happen from the d's perspective. Okay, so d is connected to b1 through the shortest. Please, somebody in a and b, please correct me if I am going in the wrong direction. Okay, so because you already everybody knows it. Okay, anyway, so D is connected to B5 and B1. Now, why did you choose? Because both are equal distance. I can reach through B7 also in one hop, B5 also in one hop, but I choose equal hop it is. So I choose the lower ID. Now, naturally, what you do, if the D is has to be connected in one way only. One more should not be there. So you can naturally actually put it dotted here. Okay, if you are not able to draw it on this, you can show it on side also. Okay, okay, so dotted. This has to be dotted. Now done. Now you see whether it has to be dotted or not. We will not take a decision actually. Now f is taken care of, k is taken care of, b is taken care of, a is taken care of. Now let us look at c. How will c reach b1? Always everybody will try to see, or you have to think, how do I reach b1 root bridge from with the shortest path? So b2 b7 is one path, b3 b5 is another path. Naturally both are equidistant, two hops, but b2 is the lower id, so I will go this path. So I will choose this. Okay, I will choose this and choose this. Okay, done. Now dotted line, let us keep it. Let us see whether now actually you are you have no option. You have connected all of them. This needs to be dotted. Okay, there is no way you can actually avoid it. Okay, better it has to be dotted because otherwise it will be a loop. So you have done it. So E you are taken care of. C also you are taken care of. E is also taken care of. Now what about G? G naturally it can go through this directly one hop. Otherwise it has to go through b6 b4 and again b7. It will be a loop. So there is no other path I have. So I have to collect this to b1. So G is taken care of. Now let us look at H. How will H reach the thing? Again these two, can it reach through this or this? Okay, either this way or this way. No, there is no other way. It will come back to b7 only. So shortest path H is to go like this, and come here. So H is also taken care of. J, what will it do? Will it choose b4 way or b6 way? It can choose, come here and then go like this, or it can go directly here. But distance wise 1 2 b1, so 2 here also 2, but which is the distance is same but b4 is shorter. So I will choose for j to be on this path. So j is taken care of. Now only I is left. Now if you by mistake, now I also, what you do, you can have an option of either connecting b6 or b4. Again, because b4 is shorter, I would prefer going here, because this also two hops, this also two hops. So I also will be like this. Okay, and now you know that every LAN is connected, you G is also connected, everybody is connected, they will remain as dotted. That's all guys you have to do. Where I am not even expecting you to remember. Okay, now what is that messages you have to write? The messages are root node, destination, distance, sorry, not destination, and own id. So each of them I have already written it earlier. You should be able to appreciate, get it. This is after the stabilization happened. Okay, now what about the b3? Okay, b3 also data. Okay, so please remember to do. There are ib, these two are invalidated bridges, and other solutions are there. You can always look at it. So you will say root bridge is b1 for everybody, and this guy will say distance as 1, this will say 2, this will say 2, this will be 2. Okay, sorry, yeah, this is 1. Okay, this is 1. Okay, that's all. Okay, which is the one bridge down the no root bridge is distance is 1, and one more level is 2. That's all. So I will not take much time. Okay, transparent bridge, I think uh, I hope transparent bridge, any doubts are there? I hope you guys know it, right? Is very transparent bridge is, I told you about, initially they do a flooding, then they do okay, let me say which is the discard. Okay, I will discard everything. I think too many things. I don't think I should save them. I will. Shall I discard or keep it? Okay, I'll keep it anyway. I can delete it later on. Okay, so already time up. So let me just look at. Okay, somebody said that some Wi-Fi. Okay, Ethernet frame header. Preamble is something which is to synchronize the clocks. SFD is to verify whether the synchronization of the clock has happened or not, because this is a 1010 pattern, not 10. Some fixed pattern is there. 1010 This is to verify that the clocks of the both no, the sender and receiver or devices are synchronized. Okay, and then you look at the thing. See, it's like this. When you are wearing a specs, you will make sure that whether you are reading it properly or not before reading the entire book, right? So similarly, Ethernet is doing something. Okay, it doesn't have any other clock or anything going between the devices. So preamble is 1010, which is like a square press, keep on coming so that they can synchronize with the clock, and then to verify whether the synchronized clock synchronization has happened properly or not, it is receiving this packet, this pattern. If it is receiving this pattern properly, that means it is pakka, it is done. Then it will look into the rest of the content. That's how Ethernet frame is. And length is actually, I have already explained it in the header explanation. What all part of the field is in length. Sir, can you please put your previous Myanmar papers? It will be easier. No, some people are saying that it is too much to go through. They will say that last minute I am sharing, and there will be a lot of complaints coming. Okay, because you don't know what to look for. Okay, so if you are thinking that I may be using those Myanmar papers as my template for the current question, actually, I have not looked at it, to be frank. I am just formulating the questions afresh. So I will do it for maybe for before the midsum, endsum or something, just for your knowledge sake. But now it will be too late, and then it will be too much for you to go through them. Okay, unnecessarily there will be questions on that, and then you will get some option will be different, and you guys will get into doubts. Okay, what type of questions can be asked? Sangamesh will always say about that.
No, sir. I mean like from this
You understand this, man, that's all. Okay, what type of question means you are asking me to tell the other question here, so I can't tell you. So understand what I mean by it, and then when you see the question, answer it. Very simple. Okay, power over Ethernet is nothing, guys. Just that the devices are not only, only Ethernet cable is connected. Okay, but actually Ethernet cable will have data cable, ground, blah 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 blah, and then power supply also is along with that. So it not only transacts data frames, Ethernet frames over the cable, it also gets power from it. Okay, that's all. When you charge it, actually, see what happens is, analogy is when you are connecting your mobile to your laptop for transferring some photos. What actually happens, it actually charges also because of the USB, and then it also allows you to transfer some files or contacts from laptop to mobile or mobile to laptop, right? Same way is the thing. PoE is nothing but that. Okay, very very simple. Now wireless technology, um, I think some doubt came, and I don't expect you to remember all these things. Okay, I told you. So this is what is hidden node problem is, right now I don't want to go and bother you about it. Um, Try to, what I'm saying is, see, if A is here and it is communicating, it is going to see whether B is communicating or not. Okay, but it will not know whether C is communicating. Okay, it does the A, you will not even know C exists. Okay, whereas B will be getting both the guys. Okay, it is like this. Suppose you are in a bridge, you are standing in a bridge in the middle. One person here, your father is here and your mother is here. Mother is saying, calling you, and father is also calling you. Now father doesn't know that mother's, he is not hearing it. Okay, so but you are in a overlap region. So when father talks, you don't hear it because mother also is calling your name. So you suppose you are able to not able to hear, you will not get both the things. Nobody, you will not even hear what the father is calling, what mother is. Now what will mother and father think? I am keep calling, this guy is not even coming here or responding back. The problem is you are actually, not able to get both of them because you are in the overlapping region, and this father and mother are not in the overlapping region, so they don't know that they exist each other. They are also communicating with you. That's the same thing is happening here. Okay, that's what is called hidden node problem. This is exposed node problem is, a little more complex, so I don't want to communicate right now. I don't want to load you here. Sir, is it like conference call? What is like conference call? No, conference call means it's like a broadcast. Everybody see in a conference call, what happens is, when you are bridge conference call bridge is there, any voice packet coming from anybody. Suppose you are having a voice call, every voice packet coming from everybody is sent to everyone. Okay, but the problem is if what you mean by that is two people are talking. Yeah, both the voice packet at that particular time will be there, will be delivered to all other guys, and they will be garbled. Yeah, you are like what you meant was like, I think, G1. So that's what will happen. Okay, I think I have completed everything. Now I want to hear whether is this helpful. Please don't think that only these are coming. Some of these what I discussed may not come. Don't scold me, or and many of the things that I discussed will come, and something which I have not discussed also will come. Okay, so please just I told you IA1, just question paper only you think. Okay, don't have to read about everything else. And in between IA1 and midsum, I already given you the topics and what to remember. And transparent bridge also you learn about it. Okay, it's there in the content, please read about it. Okay, that's all I have for you, and I think I can stop here. Okay, thank you very much. Helpful. Okay. I hope you have confidence. Don't think too much, overdo. Okay. I am not going to be too nasty on you to ask you too tough question to show my knowledge. My intent is always not that to show my knowledge. I want you guys to show your knowledge in the question paper or answer book, which I feel good about when I read it. So my intent is not to. I can actually give you a very tough question, but which I am not interested in doing it. I'm not doing it also, but I want you to think a little bit. Okay, and please, whatever you think appropriate, write it. Don't be too scared about the exam. What you know is enough. Understand what you know. That's all I want you to do. Okay. Okay, so thank you very much, and all the best for calculus also, as well as for our subject. Both exams are going to be as planned, and what I am planning to do is afternoon you are likely to have a new set of answer books, and I think the room allocation is done. Question papers, please keep it along with the answer book. Nothing other than this I am going to share. Okay, I hope you understand what I mean by that. Okay, all the best, guys, and do not copy at any moment. Okay, yeah. What's the question?
Sir, you told that you could especially for the network topology and the STP message question, like if it comes,
Hmm.
you told you could write it on the question paper instead of redrawing it, right, sir?
Yeah,
On with pencil or
pen. Yeah, yeah. You are allowed to do it. I will announce it in the exam also, because many of the people are not here. Okay. You can also pass on that if you have any other mechanism. You can pass it on to the others. Okay.
yes, sir. So like after even correction and we get back the paper with all the corrected marks, should we return the question paper then again, or can we take the question paper in that way?
Why do you need a question paper? No, I will. Anyway, you have a PDF with you, right? I am going to share it in my classroom. Probably because answer is going to be part of the question paper. You should be left with this only. Okay, you should not take it back, right? Otherwise, there will be audit question coming. How did you give the marks when the answer is not there in the answer book? It is in the question paper, right?
Yes,
So
sir.
yeah. So you have to give back the question paper along with the answer book, along with the question paper. If you are writing the answer in the question paper, and you have to write the USN number also. Okay. Question paper also you have to write the USN number. Whether space is there or not, you have to write it in the top. Okay. Got it? Yeah.
So, is it like it's for alerting the receiver stations that data is coming, or is it only for clock synchronization?
You are talking about preamble.
No, sir, SFD, the
Ah.
0
Okay. Who is on the line? Who is talking? Huh?
Avish.
Avishi. Okay. See, preamble is for clock synchronization. SFD is to verify whether the clock synchronization has happened properly or not. Okay. That's why is a fixed pattern is sent in the SFD. Preamble is just a square pulse. Okay, normally there is a, okay, I don't want to go into the electronics part of it. It's the phase lock loop is there, which will actually a hardware circuitry which will synchronize the clock, if you give it square pulses. Okay, that's the logic behind it. Okay,
Okay. Thank you, sir.
understood. Okay, um, okay, if there are no questions, I am going to stop the recording, and I don't know whether YouTube will allow me to upload such a big file.